This is the video for the Buggy Car Lab that you need to watch before we proceed in class. So just like last time, you're going to write out a lab report. This time you can use a scrap sheet of paper. The final report's going to end up being typed out, but you do need to have this stuff written down when you come into class tomorrow. So the purpose of this lab is to determine the relationship between position and time. We really want to mathematically determine the relationship between position and time. So it's going to go very similar to the other lab, where you're going to have to figure out what data to collect, and then collect that data and then graph it like before. Now, a lot of people will say determine the relationship between position and time, and they'll think that distance is interchangeable with position, and distance is very different than position. So looking at this, right, distance, the total amount of meters, miles, feet, etc. that an object travels in a given amount of time. So if you wake up in the morning and you walk throughout your house, you drive to school, you drive back home, you walk around your house, and you go back in bed, there's going to be a bunch of meters or miles or feet that you've traveled. You know, if you had one of those little pedometers, you could put it on, you could figure out how many steps and calculate how, and just figure out, I walked 2 miles today. So that would be a distance that you've traveled. Okay, so example, another one, a car drives 100 meters in 30 seconds. Now the way position is different is the first thing that you have to have for position is you have to have an origin. So let's say the origin, the starting position, is your bedroom. So if you get up and you walk around your house and you drive to Starbucks and get a coffee, and then you forget something and you drive back to your house, and then you drive back to school again, for your change in position, you wouldn't add up all those distances. You would just add up a straight line from your bedroom to the school's location. And if that measured out to be a half a mile, then that would be your change in position. It would be a half a mile. It wouldn't be all of those different locations added together. So it's relative to this origin that we talked about. And we'll talk a little more about position in class, especially if you have some answers. Some questions about it. So at the end of the day, right, school's over, you want to go home, get started on your homework, you get back in your car, you drive back to your house, you go back to your bedroom. Your total change in position at that point would be 0 because you ended where you began. So it's very different. If you took that same trip and you wanted to know your distance, it might be a couple miles, but your change in position would be 0 because you ended where you started. So if you take this was supposed to be a car right here. My starting position right here would be -1 meters because I'm to the left of this 0 meter mark, which would be considered the origin. So if I go from this position of -1 meters to this position, right, the distance I've traveled would be 2 meters, but my position right here, I'm at a position of +1 meters, right? And my change in position would be +1 meter, or sorry, +2 meters, because I went from -1 to +1, so there's a change of 2. So again, if I start at this -1 and I go from this position to here, to -3 meters, now I'm at a position of -3 meters, and my change in position is now -2 meters, because I started at -1 and I went to -3, so I went to the left 2 meters, so a change of -2 meters. If I start at the origin, go to 6 meters, go back to 0 meters, my change in position would be 0. Because I started where I began. Or if I start at 0 meters, go out to 6 meters, and come back to 2 meters, my overall change in position is only 2 meters. Even though my distance traveled would have been 6 out and 4 back in. I drove 10 meters, so my change in position is 10 meters. My distance traveled is 10 meters. My change in position would only be from here to here. That straight line distance from the beginning to where I end, it would be 2 meters. Again, we'll talk more about that in class, before you start the lab. So determine the relationship between position and time. So I'm going to stop here and show you a little video of what you're going to be looking at to try to figure out this relationship between position and time. On your scrap piece of paper, I want you to jot down some observations about the car, specifically about the motion of the car. Just anything that you notice about its motion while it's moving. Jot down some observations. Now that you've seen the video of what you're going to be working with, the buggy car, and you can see that hopefully here in an image that'll come up that you are going to have your buggy car. You're going to have a stopwatch to use. You're going to have some masking tape, and you are going to have a meter stick. So the question is, what values do you want to record? If you want to determine the relationship between position and time, and remember, you want to do it accurately, so you're going to want to have multiple trials and travel to multiple different positions. So your job here is to figure out how many different positions do you think you need to travel to, and how many different trials do you think you need to use. So when you come to class tomorrow, I want you to have a data table that you could use to measure it and come up with how many trials and how many different positions do you want that car to travel to for you to be able to get some accurate data. You're not going to put any averages and you're not going to put any totals in that data table. It's just going to be raw data, no calculations. So the last thing here, I know it's silly, is how to work the stopwatch. So you turn it on, you hit the start button, you have to stop it in order to reset it. But the useful thing is, once you start it, you can let it go for a while. When you hit a lap, it freezes that screen. So you could record this value, but the time is still running. So when I hit the button again, it'll jump forward and see, well, 10 seconds actually went by. So when I hit lap again, it freezes the screen. I can record the value. Its time still ticking. It's 21 seconds, 22, etc. And then when I hit it, it unfreezes the screen so that you can see those times. So tomorrow when you come into class, make sure you have on that scrap sheet of paper the title, purpose, and materials written down so that you have it for your lab report. I'll also be checking to make sure it's written down. Make sure you've created that data table. Make sure it has labels in it and it has the units. So whatever you decide you need to record, make sure you clearly have it labeled. Don't put an X and a Y and so on, but clearly label it with the units. And the data table should somehow reflect how many trials you're going to do and how many different positions you think the car needs to travel to. Remember, I asked you to make some observations about the motion of the car, so have those couple observations jotted down. And last thing is, be prepared to ask questions. I mean, if you guys come in and you don't have any questions, I'm going to give you a car and your materials and say, okay, go do the lab. So it's your responsibility to ask questions, and that's what I'm there for. So please ask questions if you have them. Last thing you need to do tonight is make sure you take the quiz so I know you watched this video. So again, go to the Socrative app with your smartphone, or you can follow the website shown and enter into your room 88083 and answer the 3 or 4 questions. I will see you tomorrow.